My name is Aleksa. I'm a security engineer at Praetorian, and today I'll be presenting a personal project of mine called the Impersonator Shell, where I successfully fused a reverse shell with a kernel exploit for fun and, of course, for profit. So I'll start by giving a basic overview of the presentation we'll be discussing today. I'll start by discussing the guiding ideas behind the Impersonator Shell, and you guys will come to understand how the Impersonator Shell as a utility was initially conceived. After that, we'll talk about the technical development of the Impersonator Shell, and I'll begin by discussing the basics of tokens in Windows. I'll move on to discussing name pipes and process spawning and some architectural design decisions that happen there. We'll talk about impersonation with the Windows API using standard procedures, and we'll talk about how to tie that all together with sockets in a process I like to call shellification. After that, I'll discuss the current state of the Impersonator Shell and some potential next steps, and we'll move on to a demo after that, and there'll be some time for Q&A after. So to begin with the guiding ideas, early on in my career, I noticed that every security engineer has a common set of actions they do upon getting initial access to a Windows machine. And I wondered what would happen if a remote shell could assist you with some of these actions. To give you some illustrative examples, file transfers happen to be quite common. For me, downloading a file with PowerShell is like plugging in a USB. I've always got to do it like 2 to 3 times for it to actually fire. I thought I could simplify that. Certain tools like WinPs and CrackMapExec are also widely used. I didn't see a reason as to why they shouldn't be packaged as a part of a standard remote shell binary. And last and most interestingly, I wondered what would happen if common privilege escalation attack vectors were included as a part of a remote shell. As you probably anticipated, the inclusion of reliable privilege escalation attack vector that avoided antivirus and didn't trigger EDR was the biggest challenge that I faced in creating this utility. So that's what I decided to focus on for the duration of this project, and we'll go into what that means for the presentation. I also saw that many Windows servers seem to have the impersonator privilege enabled, and exploiting this privilege requires that we transfer a file from the target attacking machine or from the internet to the target machine. And not only can this transfer process be a little tedious, as I mentioned, but common exploits that attack the impersonator privilege may also be flagged by EDR systems. And I thought this would be the perfect opportunity to attempt to maybe simplify things. So the first question I asked myself on the road to developing the Impersonator Shell was why the impersonator privilege seemed to pop up again and again and again and again. I encountered it at least once on every single network assessment that I completed. And with a little bit of research, I realized that server software running on Windows system leverages the impersonator privilege in multiple use cases, like conducting access checks and completing remote procedure calls, right? And for this reason, we can expect to find the impersonator privilege enabled on any Windows server we encounter on an internal network assessment. And for this reason, I thought that'd be a good basis for developing a reverse shell that can actually attack and abuse the impersonator privilege. From there, I wondered what would happen if I took the publicly available code for 2 widely circulated binaries, such as Netcat for Windows and Printspoofer, and stitched them together with some basic C#, right? And I thought that a simple stitching not only avoid unnecessary file transfer, but maybe it had the potential to automatically give me an administrative reverse shell, right? Unfortunately, EDR systems still pose a threat, and they can easily detect many component exploits targeting the impersonator privilege. And sometimes, unfortunately, they also terminate Netcat sessions, which for us is a problem. So I elected to create the impersonator shell as if it were remote system administration, a utility, and actually gave it the ability to impersonate users using standard Windows API procedures. From there, if I could test it on an engagement, especially one where the EDR terminated Netcat sessions and removed exploits targeting the impersonator privilege, and I found that I had a reliable way to impersonate the anti-authority system, I knew I'd be onto something. Now that we understand the basic idea of behind the impersonator shell, I'd like to start talking with the technical developments behind the tool, and we'll begin with the basics of tokens in Windows. So a token in Windows operating systems is one of the primary session management tools that the operating system uses. And a token can fundamentally be understood as a basic representation of a user and their session, right? And they contain a lot of interesting information, including the user's SID, their group membership, their privileges, and the login ID of their session. And it's important to note that when a user runs a process on a Windows system, right, that process acts on behalf of that user by assuming a duplicate version of that user's token. To discuss a little bit more about processes in detail, according to the Windows documentation, a process is simply an executing program, and they're comprised of 4 fundamental components in memory. The first being a private address space used to load DLLs. We have a private handle table used to communicate with the kernel. We have a thread pool used to manage the software threads, and we have the aforementioned access tokens. Once we have a plain English understanding of processes and how they relate to thread pools and access tokens, we can begin to discuss the process of impersonation. So impersonation is fundamentally a very simple 3-step process that involves calling the correct API calls in the correct order, according to the Windows documentation. And it begins by listing all the currently running processes on the underlying Windows operating system. From there, we can select an arbitrary target process that we want to potentially attack, and we're going to open a token handle on that target process. If we, of course, have the impersonator privilege enabled, we can use that token handle to impersonate the user with that token and call any requisite API calls within the context of one thread. If we want to execute arbitrary commands in the underlying operating system, that unfortunately involves spawning a new thread. So what we'll have to do is duplicate the token and spawn a process that will execute commands on our behalf. I'll discuss what that means in the next slide. And I'd like to begin by discussing name pipes and process spawning and some design decisions that I had to make while considering these aspects. So many of you are going to be familiar with anonymous pipes, which is what you use to pass the output of one command as the input of another in CLI, like a terminal or CMD. Name pipes function much in the same way, with the caveat that they could be referenced by a running script or a program. And they're highly leveraged for inter-process communication in the Windows operating system. Traditional exploits that attack the impersonator privilege function by instantiating a name pipe between the Windows NTLM negotiator and a TCP loopback. And the exploit in something like Printspoofer exploit involves tricking the operating system into sending a highly privileged token across that name pipe where it will be captured. Unfortunately, updates to Windows 10 and above mean that highly privileged tokens can only be sent over port 135, and I wanted my tool to be forward compatible. So what I like to do is to use standard Windows API procedures to duplicate a token off of a currently running Windows process and use it to spawn a second process that will execute arbitrary commands on our behalf. So now that we have a basic understanding of tokens and their functionality in Windows and how we'll be leveraging process spawning, I'd like to talk a little bit about the impersonation process and what that means for us. So as mentioned before, impersonation is fundamentally a 3-step process that involves getting a token handle on an arbitrary target process, using that token handle to impersonate the associated user and call any requisite API calls within the context of one thread. And once we're done with the requisite API calls, we can use that token handle to duplicate a token and spawn a new process that will execute commands on our behalf. However, there are a few caveats that I'd have to mention. So tokens have permissions as well. So just because we have the impersonator privilege enabled does not mean we can impersonate any user with any token. We have to have the proper permissions on that corresponding token. And the ability to duplicate tokens unanimously is generally only granted to a few service accounts in select cases, such as service accounts or high-level administrators. For normal users and low-level administrators, to duplicate a token requires that we enable the debug privilege. And WinLogon is a system utility used to manage logon sessions of users, and it's always going to be ran by NT authority. So WinLogon is generally a good process to target, but for any user, including administrators, it's required that we enable the debug privilege. And this, in my opinion, is the biggest limitation of the Impersonator Shell, because we're not always going to have the ability to enable that debug privilege. And I'll go more into what that means later. But for now, I'd like to give you a quick visual of what token permissions look like. As you can see here, we have a token with the impersonate privilege enabled, meaning that we can impersonate associated user and call requisite API calls within the context of one thread. We also have the duplicate privilege enabled, meaning that we can duplicate that token and spawn a new process on that user's behalf, which is of course what we want. And also I'd like to show how the process of duplicating a token and spawning a new process looks like within the context of one machine. So as you can see, I have a binary here called token.exe that's targeting process 1056. We're starting with user pentest and we're enabling the debug privilege. From there, we're opening a token handle on the requisite process and impersonating the user. And we're calling an API call to get our username. And as you can see, we've successfully impersonated the system, which is good. From there, we duplicate the token and we spawn CMD that's actually going to run as an anti-authority system. Just a few important things to note when creating a similar project like this on your own. And the first is that a thread inherits the token of its parent process, regardless of who it's impersonating at the moment of impersonation, right? Which is why we have to duplicate a token and use that duplicate token to spawn a process as another user. Secondly, impersonation might sound a little mysterious, but it's fundamentally a standard procedure that involves following the correct API calls in the correct order, right? However, standard Windows API calls are generally not enough to create an exploit in and of themselves, but we can exercise a lot of creativity in how we decide to duplicate tokens and achieve something analogous to an exploit. So now I'd like to tie this all together using socket programming in a process that I call shellification. So fundamentally, for the impersonator shell to be a shell, we need to integrate it into a minimal version of Netcat. And not only should this minimal version of Netcat be easily extendable, but it has to fit three primary criteria. It should be able to act as a client or as a server based on arguments that are passed it upon runtime. So for us security engineers, that means that it should be a bind shell or a reverse shell, right? Upon instantiation, it should have a while loop that receives commands over a socket and sends them to the underlying operating system and returns the response to us over the socket. And fundamentally, within that while loop, we have to have a nested function that's actually going to process commands on our behalf and either execute system commands or decide to impersonate users. So now that we have a basic understanding of how I've shellified the token type binary, I'd like to talk a little bit about the current steps, the current state of the impersonator shell and some potential next steps, and then we'll finish off with a demo. So thankfully, I did have the opportunity to field test the impersonator shell in a scenario where the EDR on the target machine happened to kill Netcat sessions and remove exploit that targeted the impersonator privilege, right? But we were able to use the impersonator shell on the operating system, and it wasn't killed by the EDR. And eventually, we were able, with a fully interactive shell provided by the impersonator shell, escape privileges. The second thing I realized in the creation of the impersonator shell is that the Windows API provides a wealth of powerful functionality that can be used for both legitimate system administration purposes and for security testing scenarios. And I'll be looking to add a wealth of powerful functionality that can help me enumerate the system, exfiltrate important data, and potentially even maintain persistence. The third thing that I learned, or that I learned to acknowledge, was the power of large language models such as ChatGPT in the actual creation of malware for security research purposes. And I found that they were particularly adept at transferring or translating code from C# and C++ to C. However, there was a number of cases where I asked it to write some code for me or to translate some code, and it gave me a generic legal disclaimer about how it couldn't hack. And unfortunately saying, it's all right, I'm a white hat, I'm a good guy, didn't do much in the way of convincing it to actually produce the code for me. So what I'll be looking to do going forward is to create a series of guidelines and potentially even a framework or a methodology for creating security tools using LLMs. And now that we've gotten that out of the way, I think it's time for me to give you guys a demo. right? So as you can see on the right side here, I have what I've created. I have a server that I've created called the damn vulnerable Django server. And this, by the way, was created using one LLM prompt, just to give you an illustrative example. And it was also released under the Wild West Hackfest license that I created, also with another LLM prompt. So feel free to take this and extend it for any demos you might do going forward. On the left side, we have a Netcat listener running on a Kali machine. Now, this damn vulnerable Django server gives us a very basic interface for simply achieving remote code execution. So what I'm going to do, for starters, is to run whoami/priv and see what that outputs for us. And as expected, we have the impersonator privilege enabled on the underlying operating system, right? Next, I'm going to type the command dir and see what that yields. And we're going to see that we have impersonate.exe, which is a compiled version of the impersonator shell, already on the operating system, right? So I'm going to start by running it without any command line arguments, and we're going to see what happens. In about a second, we'll see if I've done enough praying to the demo god. So hopefully this works. And as you can see, it either asks for simply a port in the event that we're running a bind shell, or a port and the remote host in the event that we're creating a reverse shell. So we're going to pass it in our host, our remote host, which I'm going to copy from config here. And we're going to specify port 4444. Yikes. Sorry about this. I'm going to do a quick sanity check and make sure that running this properly. Okay, we see our host and our port. Okay, it seems like my Kali machine was not connected to the internet, which is why this is a problem. We're just going to have to wait a minute to connect. Open meeting. Okay. So we have an IP address, which is a good thing. And there we go. That's our impersonator shell. Thank you. So I'm going to start by running, thank you. I'm going to start by running help, and we're going to see what commands we have at our disposal. So as you can see, we can use token info and we can pass the PID. to enumerate some permissions and the associated users that a token represents. And then we can use the impersonate command to actually run a command as the user we're impersonating, right? So we're going to start by typing in task list. I always mispronounce that. And we're going to look for the win log on process. That should be control plus. You know what that is on a Mac? Perfect. Right. Yeah. Right. So we're going to look for, thank you. We're going to look for win log on, which is running on with a PID of 712. We're going to copy this and we're going to scroll back down and we're going to run token info for 712. And as you can see, as promised, the associated user running win log on is anti-authority system, but it does say that we're going to need to enable the debug privilege in order to actually execute commands using the token associated with win log on. But fortunately, the impersonate command actually takes care of this for us. I'm going to start by writing a quick dir to prove that the file I'm working with, Whoami, is not going to be here. I'm going to type impersonate process 712, and to this directory, damn vulnerable Django server, we're going to pipe the output of the command Whoami, the file called whoami.txt. Right. So as you can see, we successfully duplicated the token. We impersonated system, and we ran the corresponding process. I'm going to run dir again, and we're going to see that we now have the file whoami.txt here. I'm just going to do a quick more to see the contents of that file. And as you can see, anti-authority system was actually written to that file. So we're able to successfully impersonate anti-authority and route the output of Whoami as anti-authority to this file. Yeah. Anyways, thank you very much. I'll be here to answer any questions you may have now. Thank you.
When you're calling impersonate, how do the commands, when there are events showing up in the event log,
right?
What do they show up as?
Good question. I haven't actually looked at the event log, but I am calling 4 requisite API calls. So we're opening a token handle. We're calling the impersonator. There's an actual API command called impersonate. We have a duplicate token, and we have a 4th command, spawn process with duplicate token. Those are 4 commands that I'm running.
And then is it going through that process for each command ran, or does it keep that new spawned duplicated process open?
So unfortunately, it's going through the whole process for each person or each time we run a command. And you may have noticed, but when I do run the impersonator command, it actually runs, it opens a shell on the target machine, which is probably a very big indicator that you've been impersonated. So I'll have to somehow sort this out going forward.
So for the tokens, tokens have permissions, so you can only steal tokens that you have permissions for. Impersonate tokens you have permissions for.
Exactly.
How are you able to impersonate system's token if you weren't running as system?
Right. So thankfully, if we look here, I was able to. It actually doesn't say it here as well, but in between listing the current user and obtaining the duplicate token, I actually enabled the debug privilege, which allows me to duplicate any token. Yeah. So there's only some scenarios within which you can enable the debug privilege, so that isn't ubiquitous. Yeah.
You touched on it lightly, but what was your encounter with EDR? What was its reaction kind of throughout the development process?
Yeah, so I've tested this against Microsoft Defender, and thankfully it still doesn't catch the Impersonator Shell. And we did test this against, I believe it was Carbon Black, was the name of the EDR. And it terminated Netcat sessions, and it after about 2 minutes, so we only had about 2 minutes of interactive shell. And it also wiped exploits like Printspoofer immediately. So those weren't of any use. And we were actually able to keep the impersonator shell running on that target system until we didn't need it anymore. So the EDR didn't kill that shell whatsoever, which is, I guess a good thing for us. Maybe not for the client, but for us, definitely.
So I'm not very well versed in the Windows privileges land, but what is a legitimate use for impersonation privileges? That seems like something that you wouldn't really want anyone to have.
Right. Unfortunately, impersonation is used by the underlying Windows operating system to conduct remote procedure calls. And also if you authenticate to Windows server, it's going to use the impersonate privilege to conduct access checks. And when you install server software, whether it be Apache or the damn vulnerable Django server, the impersonator privilege is actually enabled by default, even though the actual server might not need it. So it's as it stands, the impersonator privilege is something that is enabled by default, probably not used, and people don't think to actually disable it. So in most cases, you can probably safely disable the impersonate privilege without any issues. But remote procedure calls and access checks are what the intended use case of the impersonate privilege is. Thank you.